So in this video, we'll look at another technique of evaluating limits when we have an indeterminate form. So if we evaluate this by plugging in, we're going to get 1 over 0 minus 1 over 0. So this is basically anything divided by 0 is infinity. So this is basically infinity minus infinity. So remember that there were 4 indeterminate forms, and 0 over 0 was not the only indeterminate form. So you can also have an infinity minus infinity, and this is an indeterminate form. So what do we do in this case? We can definitely factor the denominators, but that is not gonna get rid of the indeterminate answer, right? So the only viable option here is to combine the two fractions, to join both the fractions into one single fraction. So in order to do that, we need to find the LCD. Now, when we go to find the LCD, it's always good to simplify the denominators before calculating the LCDs. So what I mean is that it's always good to factor out the denominators. What we need to do is we need to factor out the denominators before we go on and calculate the LCD. So we can just factor them out as the limit as x approaches to 1 over, I can put 4 outside, and this gives me x minus 2 minus 1 over, that's a difference of 2 squares, because x squared minus 4 can be written as x squared minus 2 squares, so that's just x plus 2 times x minus 2. Now that both the denominators are fully factored, we can go ahead and calculate the LCD. So to find the LCD, I'll put down the denominators separately, both the denominators, and then I need to find the smallest number that successfully divides any one of the denominators. So the smallest number that divides this one over here is 2. So 2 divides this to give us 2x minus 2. 2 does not divide the second denominator, so I'll just write it down as it is. Then again, 2 divides the first denominator to give us x minus 2, and 2 does not divide the second denominator, so I'll just write it down as it is. So now what's left is the x minus 2 and the x plus 2 times x minus 2. So what's the smallest term that divides either one of this? So it could be either x plus 2 or it can also be x minus 2. So we'll just go with x minus 2 for the sake of it, but you could go ahead with any one of them first. X minus 2 divides the first denominator to give me 1, and also divides the second denominator to give us x plus 2. So now that we have a 1 on the first denominator, so that means that this part is done, okay, because we have a 1. So the thing that remains is this x plus 2 over here. So the smallest number that divides x plus 2 is an x plus 2. So that also gives us 1, and you're left with 1 and 1. So the LCD is the product of these 4 numbers over here. So we can say that the LCD is 2 times 2 times x plus 2 multiplied by x minus 2. So hence the LCD is 4 x plus 2 times x minus 2. So now let's combine the two different fractions using the LCD. So now we know the LCD is 4 x plus 2 times x minus 2. So how we move about now is that you take the LCD, you divide it by the first denominator, and you multiply it by the first numerator. You do the same for all the different terms there. So the LCD is 4 x plus 2 times x minus 2. Divide this by the first denominator. So the first denominator we know is 4x minus 2. Okay, so I'm going to divide this by 4x minus 2, and I multiply it by the first numerator. The numerator is just 1. So I'm going to multiply this by 1. So this and this will cancel. This and this will cancel. So that gives me x plus 2. So I'm going to write down x plus 2 over here. Let's do the same for the second term. So the LCD is 4x plus 2 times x minus 2 divided by, what is the second denominator? So we know that the second denominator is x plus 2 times x minus 2. So I'm going to divide this by x plus 2 times x minus 2, and I'm going to multiply it by the second numerator, which is just 1. So this and this will cancel, this and this will cancel, and that gives me 4. So then I'm going to write a 4 over here. The sign that I'm going to put in between these two terms is the original sign of the fraction, which is a minus. So this is just going to be a minus. So now let's bring this down over here. So this basically is the limit as x approaches 2 of x plus 2 minus 4 divided by 4 x plus 2 times x minus 2. So this basically gives us the limit as x approaches 2, x minus 2 divided by 4 x plus 2 times x minus 2. So this and this will cancel, and that leaves us with the limit as x approaches 2 of 1 over 4 x plus 2. And now if I plug in, I'm going to have 1 over 4 times 4, which is 1 over 16. So now we no longer have an indeterminate answer because we use the algebraic technique of combining the fractions. So therefore, we can say that the limit as x approaches 2 of our function is equal to 1 over 16. Okay, so let's solve one more example. The limit as x approaches 0 of x plus 4 to the power minus 1 minus 4 to the power minus 1 divided by x. So whenever we have any number, let's say x to a negative power, we can rewrite this as 1 over x to the positive power. So 4 to the power minus 1 is the same thing as 1 over 4 to the power 1. 4 to the power minus 10 is the same thing as 1 over 4 to the power plus 10. So keeping that in mind, let's try and plug in first. So this is 4 to the power minus 1 minus 4 to the power minus 1 divided by 0. So that gives us 0 over 0, which is indeterminate. So in this case, we definitely cannot factor. The only option that seems available is to rewrite the function. So first what we need to do is we need to rearrange a little bit. So the limit as x approaches 0. Let's write the negative powers in terms of positive powers. So this is just going to be 1 over x plus 4 minus 1 over 4, okay, using this exponent law that we just mentioned. Everything divided by x. Now remember that when we have 2 over x, for example, this is the same thing as writing 2 multiplied by 1 over x. So using this, we can also rewrite our original limit as the limit as x approaches 0 of 1 over x plus 4 minus 1 over 4, the whole thing multiplied by 1 over x, which basically is the same thing as this. So this and this thing is the same. So now what we need to do next is we need to try and combine these two fractions. Okay, we need to combine these two fractions. So we need to calculate the LCD first. So in this case, we know that both the denominators are in their fully factored forms, so we can directly calculate the LCD. So let's calculate the LCD in this case. So we have 4 and we have an x plus 4. So the smallest number that divides 4 is 2. It divides 4 to give 2, and 2 does not divide x plus 4, so I'll just write it as it is. The smallest number that divides 2 is 2 itself to give us 1. So now since we have a 1 over here, that means that this part is done. And 2 again does not divide x plus 4, so we'll just write it as it is. The smallest number that divides x plus 4 is an x plus 4. So that divides x plus 4 to give 1, so this part is also done. So in this case, our LCD is equal to 2 times 2 times x plus 4, which is 4 times x plus 4. So now let's combine the two fractions using the LCD. So this is the limit as x approaches 0. We know that the LCD is 4 x plus 4, and all of this was multiplied by 1 over x, which means that all of this is divided by x. So we say that you take the LCD, you divide it by the first denominator. So the first denominator is x plus 4. So you divide it by the first denominator, you multiply it by the first numerator, which is 1. So this and this will cancel, and that gives us 4. So the first term we're going to write 4. The sign is going to be the same sign as it was in the original function. So I'm just going to write a minus over here. Now let's do that for the second fraction. So you take the LCD, divide by the second denominator, which was 4, multiplied by the second numerator. So 4 and 4 will cancel, and this thing gives us x plus 4. So I'm going to write down x plus 4. Again, I'm using brackets. So now let's try and simplify this. 4 minus x minus 4 divided by 4x plus 4, everything multiplied by 1 over x. So this and this will cancel out, and we are now left with the limit as x approaches 0 of minus x divided by 4x plus 4, the whole thing multiplied by 1 over x. At this point, even if we plug in, we're going to get 0 over 0. But what we can do next is that we can simply cancel this x with the minus x. Okay, so that gives us the limit as x approaches 0 of minus 1 divided by 4x plus 4. And now if you plug in, you're going to have minus 1 divided by 4 times 4, so that gives you minus 1 over 16. So therefore, the limit as x approaches 0 of the function is equal to minus 1 over 16.